In today's fast-moving technology world, public sector IT leaders must meet many demands and regulatory requirements. While the adoption of cloud services has helped agencies better meet some of those demands, it's also required CIOs to expand their thinking about some of the fundamentals like disaster recovery and ensuring IT availability. I'm Wyatt Cash with Scoop News Group, and here to talk about how those strategies are changing for public sector agencies are Alan Hill, Chief Information Officer at the Federal Communications Commission, and Andrew Davidson, Senior Vice President for Products at MongoDB. Gentlemen, welcome. And Alan, let me start with you. As agencies like the FCC have moved so much of their IT operations to the cloud, how has that changed your approach to maintaining current disaster recovery and business continuity plans, especially when thinking about the potential event of a serious cyber attack?
Thank you, Wyatt. Thank you for having me on this program. It's good to see you again. And Andrew, thank you also for participating in this panel session. First thing is, we're, as you know, Wyatt, we're moving out of our data center to the cloud. We've got most of our systems out of the data center, but we have lots of different databases, very traditional in how we do things. And so maintaining disaster recovery and business continuity is quite a challenge, particularly in the case of a cyber attack. From physical security, you got to be concerned with, but most important, a single point of failure. And that's important to recognize. Agencies aren't funded to be able to keep hot backup database or systems up in a backup scenario. So they usually have code or warm type redundancy, and that is a serious concern. It's a lot harder to restore, even with in the telecommunications industry. The primary backup circuits of the legacy approach to doing things, and now how the network has changed. Well, now we have much more advanced persistent threats that are out there, ransomware attacks that can occur. And also it's important because, trying to maintain data integrity and availability, cyber attacks can lead to data corruption and making it very difficult to recover. The disparity in technologies in a data center, from the old to the new, you can have updated technologies in your primary data center, but your backup isn't current. That can also lead to lags in restoration. Resource allocation, you're limited. Being able to have the human resources where you have dedicated resources for both your DR sites, that's difficult. And it's also difficult, from a prioritization, how you do things. Compliance requirements, being secure, just making sure that everything is meeting the compliance of FISMA, NIST 853, those types of things. There's technology limitations. And by moving to a cloud service provider, you're able to get to the latest and greatest in terms of technologies. There's the human factor also, making sure they're trained. Where now in the cloud, you're able to have things that are much more automated, disaster recoveries. The funding cycles is one of the challenges. It takes a lot of CapEx to keep traditional data centers up to date. Where you move to an OpEx approach, anything as a service, as you know, I very much believe as a service model. I think that's a huge value, because the vendors out there making those continuous investments, keeping the technology up to date, making sure that we have improved resilience. And so that's, I think, is extremely important.
And then a quick follow. What steps has the FCC taken, Alan, to improve the resilience and ensure the high levels of data availability and also integrity?
So, I'm a big fan of journey mapping. And what we've recently completed is a digital mission roadmap that focuses on 4 key mission priorities: modernization, optimization, full stack observability, and zero trust. And from those priorities, for example, modernization, a cloud migration framework we've adopted to move things, the one that we have scalability, flexibility, and bringing cost efficiency. We're doing this cloud first mentality, but then leveraging those technologies in the cloud where we can get real-time analytics and trend analysis. Being able to automate things, orchestration between a multi-cloud environment, which is extremely important. Make sure we streamline operational workflows. developing standard automation platforms that eliminate repetitive tasks and improve overall productivity. From an optimization perspective, prioritization is really bringing operational efficiency, adopting agile approach models that allow us to align our resources, strategically implement things in a way that helps us reduce our overall cost. Implement a DevOps approach, really making sure that framework's in place that enhance collaboration, streamline development, and accelerate the development cycles. You know, the legacy approach takes a long time. We got to get to where we have basically agile on-demand capabilities to deliver capabilities. Portfolio management, building out our capabilities in a matrix approach is what we focus on operational excellence, and making sure that we consolidate operations to reduce operational spend and enhance our utilizations. Again, as I said, everything as a service is extremely important. You know, moving to service level agreements, operational level agreements, things like that, where you have guaranteed services. Full stack observability, being able to see everything is so important. The user experience from a security perspective, event aggregation analysts, and then moving to zero trust. That collection of all that telemetry coming in, that security framework that we need to work at, being able to create, for example, conditional access, you know, multi-factor authentication. That's important. And you can't do that without that telemetry. Being able to recognize anomalies in the network. If there's east-west type activity occurring, being able to recognize that immediately in a traditional data center, in a traditional way of, even in the cloud, of traditional infrastructure as a service, platform as a service, those are outdated ways of doing things. Moving to serverless environments, microservices, being able to have that full operational telemetry to see everything occurring on the network so you can focus on the customer experience, make sure we have resilient solutions in place, being able to automatically fail over to new locations if a cyber event occurs.
Appreciate that. So Andrew, let me bring you in here. How have you seen the cloud and modern data management platforms, you know, providing government agencies greater assurance and support to ensure overall resiliency?
I thought Alan, you know, really kicked this off in such a helpful way. When you think about all the surface area associated with all of those necessary critical functions, each of those things that he was mentioning requires you to really think about, what are you doing? What software are you building or using to take advantage of and mitigate and layer in all the necessary controls? And what that means, of course, is you need to be able to operate at the right level of abstraction. If you're down kind of in the, you know, lower level, having humans in the mix with your hardware and a bunch of humans in the mix with your virtual machines and a bunch of low level config details, you have a lot more risk. And of course, what cloud lets us do is abstract away a lot of those back end details so we can look at that bigger picture. But, you know, I think it's important to understand that that only works if we sort of trust how underlying cloud building blocks work so that we can feel like we can abstract it away and feel confident. And, you know, certainly in our case, coming from MongoDB, you know, a modern database company, the way we think about kind of explaining that back end and the transition from the old way to sort of this new modern posture is, you know, maybe useful to think about what matters to a database company. At its core, starts with security. You have to preserve that confidentiality. Then the second priority is durability. Data that you're writing that's core to your software, core to your mission, must always be there when you need it later. I mean, it's just a fundamental thing. And only then does, you know, availability and performance and scalability sort of come in. It's an order of operations or order of importance thing. And if you think about the databases that were built for the data center era, generally speaking, they were not on the back end distributed systems. They were the kind of thing that you would have to vertically scale up. And of course, that had a lot of cost consequences. And frankly, they weren't optimized for high availability. What that means is they were not distributed systems that could have built-in auto failover. And MongoDB from day one always was a simple and easy to understand distributed system. The kind of thing where, you know, you had multiple replicas and they would do their own consensus and guarantee that there was an election to keep write availability, even in the event of a rack or data center region or even cloud provider failure, depending on the posture you want to take on. And of course, that ability of being a distributed system, once you bring it to the cloud, as we've done in MongoDB Atlas, available in the Gov Cloud with Atlas for Government, for example, you now have that easy ability to just decide where in the world do I want to deploy, which Gov Cloud region or the commercial region do I want to deploy into? Do I want to go multi-region? Or do I even want to go multi-cloud and take advantage of that highly available posture, making it easy for you to reason about? Now, of course, the database doesn't live in isolation. You're going to have an application tier and all of the complexity that comes with more and more components that go in to a modern application. Well, the beautiful thing is with MongoDB, you can consolidate and simplify without needing as many building blocks. A modern application will look like typically a Kubernetes app tier and a MongoDB database without needing a bunch of separate engines, like a search engine that needs to be looked after separately, because we have integrated search as an example. But we also, we think about kind of high availability. It goes beyond just, can you be resilient to hardware or data center level failure? You also have to think about the needs of your end citizens, your end users, your internal users. If they're coming up and down with major demands throughout the week or the year, are you able to scale up and down? Are you able to elastically deal with that demand curve, or think about long-term scale requirements over time? And that's where, again, the distributed system really helps. You can both vertically scale with no downtime on the back end, taking advantage of that distributed system. And for long-term, you can take advantage of horizontal scale out with what MongoDB refers to as sharding, where essentially you start spreading your workload across more and more machines on the back end. And that allows you to really be able to scale in a limitless manner without running into exponentially growing cost concerns. So that's all important. But that's availability. And you think about kind of the broader disaster recovery and durability story for a database like MongoDB. It's vital that you think about having point-in-time backups that are comprehensively available, always on by default, and then optional capabilities that you can layer in on top. For example, we have the ability to have backup snapshots stored in multiple regions. You can configure that easily. Or the ability to set up a backup policy that actually makes it so that you can't even delete your own backups. What that does is kind of sets you up so that if you were to, in some sense, have an inside threat that got to the point where actually they could potentially start harming your own access to your own data, you'd be preventing yourself, aka a future threat actor inside yourself, from deleting your own backups. And of course, there are further things you can do. That's all about, do you trust yourself? And then separately, there's a question of, can you trust us as a service provider? And there are ways for you to make sure that you're routinely backing up your own backups from us to your own environment. And your own object storage will push those backup snapshots to your S3, for example, if you configure it that way, so that you have a variety of different options to maximize for a variety of different potential eventualities. And I think the key point is, going back to what Alan said, all of this is easily declarable. You can manage it in code today. That's the beauty of the cloud. And if you can manage it in code, you can introduce change review and change management, and you can empower new teams to really have a massive impact without having to throw huge groups of people at every problem. And of course, the more people involved sometimes, the more complex and risky things can become. And I think the beauty of cloud is to enable those small teams to have that big impact.
So lastly, gentlemen, how are agencies in the public sector ensuring that they also have the means to keep up with the relentless growth in data and the need for performance and availability going forward, especially as agencies are now facing a future where AI workloads will become so important? Alan, how are you planning ahead for that?
I love the question, because we're in the midst of getting out of a data center. We expect to finish by the end of the year. And so 2025, we're going to take all these databases, we're going to rationalize them, look at how we're going to modernize, leverage and modernize native and service providers that provide newer technologies in the cloud. We want to leverage things like microservices, serverless environments, codeless technologies. For example, microservices architect, you're able to modular design things. That's extremely important. You want to move out of that traditional monolithic approach of deploying things and be able to have services that are small, easy deployment packages that are independent, that can scale to individually, providing greater flexibility and resilience. independent deployment is so important because we got to be able to, potentially modernize something that is new, that requires new modernization of a capability, but also bring on new capabilities without breaking the system. Is extremely important. From the data management perspective, we need scalable storage. Cloud-based data warehouses, for example, data lakes offer different capabilities, allowing organizations to manage large volumes. Elastic compute resource is extremely important. It's important to streamline that data processing. For example, microservices and modern data platforms enable real-time ingestion and processing, allowing for immediate insights and decision-making. Being able to do things, advanced analytics, data management solutions that supports advanced analytics is so important. Enabled to, leverage machine learning and artificial intelligence, giving us that deeper insight and predictive capabilities. Eliminating data latency. From a traditional old way of doing things, extract, load, transform, process, that creates latency, but it's not real time. It involves patch and process. We're going to eliminate that. We want to remove those delays, having continuous data integrations, and not have duplicate data. And so we can have real-time updates, currency, improving in accuracy and reliability. Having single source of truth. We don't want to have multiple instances where we're questioning that. That single source of truth is so important, particularly in concerns with artificial intelligence today, making sure we have good data. Being able to provide data coverage in a multi-cloud environment, having data consistency and also the data validation. It helps us from the perspective of the taxpayer, especially our spend. These allow us to do in a data center, you're paying that CapEx, but you're also keeping it up. And when you put a server in place, that's a sunk cost. Well, being able to do a pay-as-you-go type model helps us to spend what we need to do at the time of delivery. And a lot of the systems we have are transactional in nature. And because they're transactional in nature, we don't have to have that system running 24/7. When a user comes in to put a query in or to be able to submit a license submission, that's transactional. So we don't want to have things running all the time. We want to be able to pay as we need to consume. And that helps us, optimize our resources. It also helps us reduce development time. More importantly, from a security perspective, in the cloud environment, we have the security built into the technologies. We're not, in a data center, we're building it in. In the cloud providers, we have that already built in. Being able to make sure not only we're compliant, but we're able to do things in terms of like zero trust, being able to encryption and data masking as necessary. Role-based access control, extremely important to be able to do that. That's necessary. Making sure that only access is given at the right time to the right person, as an example. And that helps us to have a lot more agility and innovation, faster development cycles, improved collaboration.
Appreciate that. And then, Andrew, what else would you add just briefly? Scaling obviously is one solution, but when we talk about performance and availability, what else would you recommend that public sector CIOs really be thinking about as we continue to see this explosion of data?
Well, I thought Alan kind of nailed it with respect to something that I was mentioning too. When you're empowering smaller teams to build really and own their own services, whether you call that microservices or just different teams building different things, and giving them the ability to self-service into their cloud infrastructure, like an MongoDB Atlas database cluster, being able to easily from there, power the full requirements of an application, operational, transactional with search and vector search. That allows them to build AI-powered applications, Gen AI-powered applications as well, which is where a lot of people are being pulled towards right now. And I think that consolidation into a smaller set of building blocks that a small team can really move mountains with is very appealing to people with great security defaults. We spend a lot of time kind of building those landing zones that help people adopt in a way that's, easy to understand and kind of following the mission guidelines of the agency. But I think there's also an interesting thing going on here, which if you zoom out, so much of the spend and data gravity still remains focused on these legacy environments. And everyone's trying to break free of those. And there's an interesting trend with AI where AI is starting to make it easier to imagine modernizing off legacy. You can start analyzing code bases and start actually rewriting certain classes of applications to take advantage of modern building blocks. So, all of that allows you to achieve the performance and scale benefits of cloud, which are many. We haven't talked about all of them, including tiering to object storage economics and many other things. And I think the key point is there's both a pull to cloud right now to take advantage of AI, and modern technology like MongoDB is a big part of that pull, but also a push to get off legacy that's becoming lower in activation energy required as it gets easier to modernize. And that's a really exciting moment for everyone.
Absolutely. Well, Alan Hill and Andrew Davidson, thank you so much for sharing your perspectives on just what it takes to, continue to focus on disaster recovery and availability, but increasingly also be prepared for all the other things that are possible moving to the cloud. So thank you both very much for joining us.
Thanks for having us.
Thanks for having us, Wyatt.